Okay, in this final video we're going to look at how we can take the equation for the kinetic theory of a gas and find out how we can use it to look for the internal energy in a gas. So in the last video we discovered, we derived this equation here, which is pressure times volume is a third times the number of molecules times the mass of molecules times the mean square speed of the molecules. Now that, of course, remember, is the root mean square speed squared, but it's the same as the mean square speed. Now, obviously, mean square speed is a bit like v squared. It's to do with energy. Okay, mass times velocity squared. We've got an energy term in here coming out. If we multiply both sides by by 1.5 v upon 2, then this side we can turn into take the n on the outside of it first, take the n to the start, and we can turn this into a half mc RMS squared, or mean square speed. Of course, this side becomes 3 upon 2 PV. Now, this is significant, very significant, because what this tells us, this little term here, that's the average kinetic energy of one molecule. This is the number of molecules. We need the average kinetic energy of one molecule and the number of molecules. Then what that's telling us straight away is that's the total energy, or total internal energy of the gas. Okay, so straight away we've got a new equation here. If we want to know the total internal energy of a gas, all we need to know is the pressure and the volume of the gas, and we're away. That's all there is to it. You know, it's 3 upon 2 pressure times volume. We go back to what we looked at in the fourth video, where we derived the ideal gas equation, as opposed to the kinetic gas equation, the ideal gas equation. We said there's two versions of it. Pressure times volume is nRT if we're talking about numbers of moles of gas, or pressure times volume is nKT if we're talking about the number of molecules of gas. Okay, now straight away we know that 3 upon 2 PV equals this lot. We can substitute this in for there and say 3 upon 2 nRT is equal to this lot, which of course we now know is the total energy of the gas. So we could say, well, 3 upon 2 PV is the total energy of the gas, or 3 upon 2 nRT is the total energy, the kinetic energy of the gas, total energy, sorry, of the gas. Additionally, if we wanted to sub in nKT into this bit for PV over here, we'd get 3 upon 2 nKT equals n times by a half m mean square speed. And so we've got n on both sides, which means we can get rid of the n from it, and then what this tells us is this, remember this here, this term here is just the average energy of a single gas molecule. And so if we want to know the average energy of a single molecule, well, and we know the temperature of the gas, that's that simple. We can basically say, well, it's a 3 upon 2 Boltzmann constant times by the temperature of a gas. And this is something that's super simple, this little idea here, for working out this, the energy. And once you know the energy, you can then say, well, if you know the mass of a molecule, which is easy to do because you can tell that from the molar mass of the molecules themselves, you can then work out their speeds. And that's what you're going to find is probably the most likely thing to come up in the exam. Okay.